The effects of burning and mowing on the physical properties of soil and grasslands. Grasslands in America and worldwide are incredibly important resources for myriad reasons. However, we place high demands on our grasslands, and quite often we have unreasonable expectations. The impact that we have on grasslands and the soil beneath them is just now starting to be closely examined, although it had been noticed as early as 1936 that we were rapidly destroying this valuable resource. In a letter to the United States Senate entitled "The Western Range," the Department of Agriculture notes that further evidence of neglect is failure to regulate the use of rangelands in such a way as to maintain the resource. The result is serious and practically universal range and soil depletion, which already has gone far toward the creation of a permanent desert over enormous areas. This was in 1936. They're already realizing these problems. The American grasslands extend from just west of the Appalachians to the eastern edge of the Rocky Mountains. In Ohio, there's tall grass. In eastern Nebraska, we transition to mid-height grasses. And finally, brush and shrubs in the far west. All of these grasses are important for their productivity and soil stabilization. Overuse and mismanagement of ranges could lead to exactly what the Secretary of Agriculture, Henry A. Wallace, warned of: a permanent desert. Now that we have established just how important grasslands are, how do we properly manage them? The first and oldest method of grassland management is fire. Fire is how grasslands have been controlled and managed long before mankind came into the picture. Thus, mimicking nature seems a logical choice. However, even with something as simple as fire, it leaves many questions unanswered. How much does fire help? Does it promote erosion? Does it increase production? How does it affect the soil? The alternative to the obvious fun of feeding your inner pyromaniac is to mow or clip the grass. Once again, what happens? Is it better or worse for production? Is the soil more organic or less organic? The answer is, it's inconclusive. That's the answer. Every soil is different, and although there's an enormous expanse of grassland in the United States, no two places will behave in exactly the same way. So let's take a closer look at the root of the issue, the soil. The health of the soil is directly related to the health of the grass, and to measure health, we need to measure the physical properties. No two papers have looked at the exact same physical properties, so this will be an overview of what has been done thus far. In the 1950s, Ehrenreich used a native prairie in Iowa to gauge biomass production in burning versus clipping. They found that burning caused plants to grow and mature quicker than the clipped plots. They believed that the exposure of the dark soil to the sun allowed it to absorb more solar energy, keep the seeds warmer, and lead to an earlier germination and faster growth. They noted that temperatures were consistently higher for the burned plots, as were the yields. They also noted that mowing, overall, resulted in less yield, especially if it was mowed frequently. So here are their plots. On the far left we have the unburned, then we have burned, burned, and burned in both 1954 and 1955. So I don't know if you can see that on the silly projector. So this is 54, and this is 55. And you'll notice that the unburned has a total yield in tons per acre of probably like 1.7, whereas the burned in 1955, burned in 1954 are higher, and the one that was burned in both years is also higher than the unburned. So there's proof that burning actually aids in yield, which is the goal. In Kansas, Clinton E. Owensby and John Bruce Wyrill III found that bulk density was not affected by burning on their plots. The unburned plots had no major change, and they noted that they expected at least some physical change from the burning, but it was undetectable in the bulk density. They cited others who had done work on the same plots and run infiltration tests, and they found that infiltration had in fact been reduced on the burned plots. They did find that the chemistry varied widely over plots burned depending on the season, and they found that the organic content fluctuated as much as 0.3% between the early spring burn and the mid to late spring burn. In fact, both the winter and early spring had more organic than the unburned plot. So here we can see that the density remains largely unchanged. The unburned plot is 1.093, 1.093, 1.051, 1.037, 1.082. And over here on the organic matter chart, we can see that the unburned plot has very little organic matter, and the early spring burned plot right here has the most. Winter burned also had a lot, but mid-spring burned and late spring burned actually damaged the amount of organic matter there. Emmerich and Cox added to the list of properties that turn up inconclusive. They set up a well-designed experiment with a seemingly foregone conclusion, which turned up entirely the other way. They set up a rainfall simulator so one plot was burned and the other plot was unburned. And you think there's more water, there's less grass on the burned plot, there's more erosion going to happen, right? Wrong. There was no difference in the plots. Nothing statistically relevant. And a fresh burn will not negatively impact the erosional properties of the soil, which was a very interesting conclusion. So Schatt and Stubendijk and Bragg, Smart, and Doran used the plots out at UNL and Glacier Creek and did a paper entitled The Soil Quality Response of Reestablished Grasslands to Mowing and Burning. They compared infiltration, bulk density, and chemical properties of sites that had been burned versus mowed. This appeared to be one of the more complete works on this subject and has lots of good data. However, this does not mean that it came out conclusively. They described any changes that they found as minor or short-lived, while others had found evidence that fire affects nitrogen content in the soil. This study found no change in nitrogen content. pH was also largely unaffected by burning, and they also found no noticeable change in bulk density. However, infiltration did see a change. The frequently burned or mowed plots saw slower infiltration times. So here we have our control plot, which has an infiltration time of 6.9 minutes. And then our 4-year burns right here all see the least amount of action. The annual burn, the mowing, all of those have slower infiltration times of 10 or more minutes for 2.5 centimeters of water. And the control and 4 years are 6.1, 6.5, 8.5, and 6.9. So burning and mowing definitely increased infiltration times on these sites. So really, all of this important research into practices that we've been using for hundreds of years needs to keep going. The literature has not looked thoroughly enough at this issue to determine if burning or mowing are sustainable for the long haul. The questions being asked involve an entire ecosystem and are hugely complex situations with no simple solution. Therefore, the only option is to break down every individual component and rebuild the big picture with a more thorough data set. We need grasslands, and they're an incredibly important part of our ecosystem. They provide oxygen, they act as a carbon sink, they prevent erosion, and they're also an important part of our economy, providing feed to livestock operations. Without grasslands, driving through western Kansas or North Dakota would be even more boring, if that's humanly possible. We need to understand grasslands and the impacts that our management practices have. The first step is to find out more about the effects that they have on the soil.